next method to think about is trigonometric substitution. So if you see a square root of a squared minus x squared, or a square root of x squared plus a squared, or a square root of x squared minus a squared in your problem, you should think about substituting x as a sine theta, or x as a tangent theta, or x as a secant theta. And so you have to be careful. Remember, a in each of these, we're thinking of some particular constant. So maybe this would be 9 minus x squared. So in that case, this is 3 squared minus x squared. Or this might be 16 plus x squared. So that would be x squared plus 4 squared. Sometimes you might have to do a little bit of manipulation. So if you have something like, let's say, 25x squared minus 16 here, so that doesn't quite fit the pattern. But if we factor out a 25 from under the square root, this becomes 25 times x squared minus 16 over 25. And so this is 5 times the square root of x squared minus 16 over 25, x squared minus 4/5 quantity squared. And so now we're thinking of here a would be 4/5. So yeah, so that's what to look out for if you see these square roots or things like, even though it doesn't have square roots, that's something that you can think about. Let's see an example of this. Let's say I ask you to integrate x squared plus 16 to the minus 3/2 power. So according to this chart, we should be thinking of the substitution that x is equal to, in this case, a is 4. 4 squared is 16. X is 4 times tangent theta. Dx is 4 times secant squared theta d theta. And when you plug in x squared plus 16 to the 1/2 power, when you plug in x is 4 tangent theta in here, after simplifying, this ends up as 4 secant theta. So putting all of these pieces together, we end up with the integral of, so this raised to the minus 3/2, well, this raised to the 1/2 is 4 secant theta. So we have 4 secant theta raised to the minus 3 times, what is dx here? 4 secant squared theta d theta. Okay, let's simplify things. We have a 4 to the minus 3, so that's 1 over 4 squared, or 1 over 16. And we have secant theta to the minus 3 times secant squared theta. And so this just ends up as secant theta to the minus 3 times secant theta squared is secant theta to the minus 1. So 1 over secant theta is just cosine theta. So antiderivative of cosine theta is, of course, sine theta. So we are almost done with this. The last thing that we have to do is, of course, is substitute back in terms of theta. So our original problem had x's in it. We can't stop with thetas. So how do we do that? We draw a right triangle. Let's label this theta. We want tangent theta to equal x over 4. So how do we accomplish that? Okay, here's a right triangle, and theta's there, such that tangent theta is x over 4. Pythagorean theorem tells us that's the square root of x squared plus 16. And so from our triangle, we can see that sine of theta is x divided by square root of x squared plus 16. Okay, so our final step would be replace sine theta with x over square root of x squared plus 16. So that is an example of using trig substitution here to evaluate integral, and the key things to look for are these kinds of expressions there. So the fact that we had x squared plus 16 raised to some power, and the power is divided by 2, that's kind of that's the red flag. Maybe not so much a red flag. That's the tip-off. That's the giveaway that we should be thinking about this approach.